All right. Well, I got an early Christmas present, a little COVID. So I figured I'd make a little video for you guys, talking about these, going through a few of the examples, and then you guys can do some homework. Anyway, so this week we're doing proofs, everybody's favorites. So a good way to construct a proof is to start with a goal and work backwards. So we're being asked to prove that CD is bisects angle ACB. So we're going to start with a show. So if I'm going to prove that this bisects this bigger angle, then what I need to do is prove that angle ACB is congruent to angle BCD. In other words, this is congruent to that. So how can I prove these two angles are congruent? They could be corresponding parts of these two triangles. Can I prove that these two are congruent? So yes, they are corresponding parts of possibly congruent triangles. Can I prove these are congruent? Well, let's start looking at all my given, right? So AC is congruent to BC, AD is congruent to BD, and then we have a same segment. So yeah, I think we're going to have we can prove side, and I've marked the given information on the diagram. So this is a dart, these are congruent, this is congruent, and then we'll work from there. So first of all, I'm going to state the given. I'm going to state the given because that's where you always start. So I'm going to say dart ABDC with AC is congruent to BC, and AD is congruent to BD. And those are given. Then I'm going to go back up here and I'm going to say CD is congruent to CD because same segment. And so then I can say triangle ACD is congruent to triangle BCD because side. And then I can say that angle ACD is congruent to angle BCD because CPCTC. And now I can say that having those angles be congruent proves that CD bisects angle ACD. Yeah, so we can kind of move away through all that, and we can say that because definition of angle bisector, which is just that it divides them into two equal congruent triangles, and so then that means it bisects the angle. Anyway, so there's the front one. So here we go in the back. Show that the diagonals of a rhombus divide a rhombus into four congruent triangles. So we're trying to prove that these are all the same. And we're being asked to show that ABO, CBO, CDO, and ADO are all congruent. The goal is to prove that all the triangles are congruent. Being a rhombus, then we know all sides are the same. That gives us a side. Boom, 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 boom. The sides are perpendicular, so those angles are congruent. Like here and here and here. Alternate interior angles would be these two. Okay. And then these two would also be alternate interior angles. And these two and these two. And the angles bisect each other. And some more sides are congruent. So more sides are congruent. So in other words, we could say these angles are congruent, yada yada. So let's so first, this one that's all written up here is a proof using side, side, side. So we have rhombus is given, and so then AD, BC, so AD is congruent to BC, which is congruent to AB, which is congruent to BC, which is definition of rhombus. And then DO is congruent to OB, and AO is congruent to OC, also definition of rhombus. And then within the triangle, we can say DO is congruent to DO, and OB is congruent to OB, same segment, so that we get these triangles. And then, let's clean this up a little bit. So we have all the sides, that because rhombus is defined as all the sides. Then we have that this is congruent to this, and this is congruent to this. And then we go through, and then we're doing same segments, so that they're, not only is this congruent to this, but this is congruent to this. So these two triangles have those. So then all of a sudden, so AO and OC, so then that gets these, and then triangle AOD is congruent to triangle AOB, and COD with COB, and all of them we have side, 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 and check, we're there. Now, if we wanted to do side, angle, side, a lot of the steps would be the same. It just, because then we could throw in some angles. So we know that so then we know a bunch of the same sides and stuff, but if we wanted to prove some angles are congruent, we could say that this angle is congruent to this, this angle is congruent to this, and then we would have side, angle, side. So now another property of a rhombus is that the diagonals bisect the angles of a rhombus. Okay, and so that tells us this. So let's start with a rhombus. So we'll start with the given rhombus ABCD, and that's a given. And then that tells us all of the sides. So we can just bring this one over here. AB is congruent to DC, which is congruent to AB, which is congruent to BC, because definition of rhombus. Then we can say we'll bring the same one over here, and so then we'll have a side, we'll have these sides congruent. DO is congruent to OB, because definition of rhombus. Then we'll need to do some same segment. So we're just worried about this, boom, angle, boom, right? And so then we can say DO is congruent to DO, so within these two triangles, and OB is congruent to OB, same segment. Now we have to prove the angles. We can say that ADO is congruent to CBD, angle ADO is congruent to angle CBO, and angle ABO is congruent to CDO. Both of those for alternate interior angles, okay? And then we can say that angle ADO is congruent to angle CDO, this one, because the diagonals of a rhombus bisect the angles, and so then we can say that angle ABO is congruent to angle CBO because def of rhombus. And so then we can say that we have side angle side. So we can say triangle AOD is congruent to triangle AOB is congruent to angle COD is congruent to triangle COB because side angle side. Now there's actually lots of ways we could have done it because we have lots. We could have done angle side angle, could have probably done vertical pairs in here because we know that these are perpendicular, so we know these are all 90 degrees. There's lots of ways you could have approached it, just figuring out which one's the fastest. So now the rest of these, you're just practicing your skills. Each conjecture has also should have been stated as given or show. Complete a proof of each conjecture, then you can use it in the following proof. So what that means is, after you've proved that the diagonals of a parallelogram divide the parallelogram into two congruent triangles, then you can use that in later proofs on the next pages. Anyway, don't forget that the answers are on the website, and have a good break.